Welcome back. So far, we have looked at using Pandas in isolation or scikit-learn itself. In this video, the idea about exploring a dataset of Pandas is to combine the two problems and show you how we can use Pandas and something like scikit-learn together to explore a real-world machine learning problem. In N2, in the first line, I'm first importing pandas as PD, as usual, and I'm simply importing a very simple dataset from the scikit-learn datasets module, the iris datasets, so very familiar with all of you guys. The next thing I want to do is to get the actual data. In any supervised machine learning problem, the data comes in sort of two components. The first component is the features, which we use to predict the labels. And the second component is the correct labels in which we can use to teach the machine learning model. Therefore, in N3, I am assigning a tuple of values into the variables features and then labels by calling the load iris function, specifying with a keyword argument that we want to just return x and y. We set this keyword argument return xy to true, such that load iris gives us back the features and the labels that are relevant to us. The next thing we want to do is to transform these features into a Pandas data frame for us to execute all sorts of summary statistics and other transformations on it. In N5, because of the magic of Pandas, we can simply feed the features variable, which currently is a NumPy array, into the Pandas data frame constructor, and out comes df, which is the Pandas data frame that contains the 4 features that we need to look at. But one of the main issues is when you are doing machine learning, creating a model that can't predict unseen data is an issue. To get around this issue, we generally use the train test splits function to split the datasets into a training set and a testing set. The idea is we'll train the model and perfect the model on the training set and expose it to the test set which it hasn't seen before, and evaluate its performance on the test set as a proxy to what happens when the model sees some unseen data. Now, how is this relevant now? It is relevant now because when you're using Pandas to do data analysis, you don't want to mentally or humanly learn from the data that your model isn't seeing, right? Because what that means is some of the information and learnings from you looking manually at the entire dataset is going to leak into what the model knows. So you get an unnaturally high score when the model looks at the test sets, but that's not because your model is good. It simply means that you have done some analysis on the test sets and transferred this information to the model instead. So the proper way to do this data exploration is follows. In N6, from the submodule model selection under scikit-learn, I'm importing train test splits as a function. In the second line, I'm assigning 4 variables as a tuple, xtrain, xtest, ytrain, and ytest, by calling the train test split function to get 25% of the dataset as a training set and 75% of the test as a test set. So now we are confident in taking this data and understanding it Pandas. In N7, I'm first creating a new data frame by calling pandas.dataframe on only the xtrain matrix. I'm creating a new column called label in line 2, and I'm assigning the ytrain series into the values of this column. If we inspect df, we can see that we have the features on one side and the label on the other side. Now we can manually look at some of the patterns, for example, the values of all 4 features being higher when the label is 2 and being lower when the label is 0. We can notice these sorts of patterns and help us inform how we think about creating a model later on. To not have all 36 or 150 rows appear in front of us and become very confusing, we can simply focus on the top of the data frame. In in8, I'm calling df.head, which simply gives me the first 5 rows of the data frame. Not only does this reduce the amount of information that I'm exposed to, it also allows me to very quickly check whether a large data frame has been constructed correctly by inspecting the first few rows. The next thing we might want to do is to check out the averages across the features. In in10, I'm calling df.mean, which takes the mean over data frame, and I'm specifying the first axis by putting in the number 0. We can see that for each feature and the label itself, it's giving us the mean, so we can see that the first feature is roughly at around 6, and the third feature is roughly around 4. The label itself is actually 1.18, which tells me that there are more classes in this data set. There are more of the second class, i.e. the class with a label 2, than a class with a label 0, based on how the mean of the labels are shifted towards 2 instead of 0. At the same time, we can look at the average of features across the data frame, and when we use the second axis, i.e. mean 1, we can see this. To save some time, we can look at the main summary statistics by calling df.describe. And one of the main things that we would like to do sometimes as well is to see which data point has the maximum or the minimum value based on the features. The way to do this in Pandas is to use the function idxmax and idxmin. idxmax shows us the index at which a feature value maxes out, and idxmin shows us index value at which a feature minimizes. We can see here that the maximum value for feature 1, for example indexed at 0, is index 23. There's also this idea of a value count. We can first use df.lock, which slices the data frame, and by providing a column in the first element of the tuple, it means that we want to look at all rows, and in the second element of the tuple I'm providing 2, which selects the second column. And by calling value counts on this column, we can see the counts of the values in the third feature in this dataset. Now this is not very useful because there's a large list of values that we're counting. What we really want to do is to bucket these into different intervals. Pandas.cut in in21 does this exactly. We again take the second column, i.e. the third feature, and we specify that we cut this 4 times. You can see in out21 that each row gets transformed into sort of an interval, but it's still not very informative. What we need to do is actually take these intervals, which there are 4, and call value counts. In in22, that's exactly what we're doing. In in22, with pandas.cut, we are cutting the data frame into 4 buckets, and we're calling the value counts and counting how many data points are in each bucket. So after we've gone through Pandas, it's time for us to move on to look at visualizing summary statistics on our datasets, and check it out next video.